This will be our second video in our initial look at basic trigonometry. In the first video, we looked at all of the vocabulary and the important terms that we will be using. So now, in this video, we'll actually start applying that. So example 1 here. Draw the angle theta in standard position where 3, 7 lies on the terminal side. Find the values of all 6 trig functions. So our vocabulary is important here. We have to understand what that's telling us. So if we have the point 3, 7, so 3, 7 about right there, so label that 3, 7 on our terminal side, then that means it's in the first quadrant here, has to be. So there's our R value right here. This is our X value. This is our Y value. So right now we don't know what our R value is. So I'm going to erase that because we'll put the actual R value when we find it. So we need to find the R value. So basically we have a triangle here with a height of 7 and a base of 3. That's what we have. So we have a right triangle to be more specific. Therefore we can use the Pythagorean theorem to find this hypotenuse, which is our R value. So that would be our R value squared is equal to 7 squared plus 3 squared. So R squared equals 49 plus 9. So R squared equals equals 58. There we go. Square root. So R is equal to the square root of 58. We need that. We need X, Y, and R. That'll be the most common definition of the trig function we'll use is the X, Y, and R in this unit. So square root of 58 is our R value. So I'll write that up here. X equals 3, Y is equal to 7, R is equal to square root of 58. So then we apply our trig functions. We need all 6. So cosine order doesn't matter. We could start with sine or cosine, it doesn't matter. So cosine theta is equal to X over R. We defined that earlier. So that would be equal to the 3 over the square root of 58. We need to rationalize this denominator. We don't want to leave a radical in the denominator. You've done that before in previous classes. So square root of 58 over square root of 58 is what we're multiplying that by. That's okay to do. That's just equal to 1, so it's okay. So that gives us 3 square root of 58 over 58. So 3 times square root of 58, 3 square root of 58. Square root of 58 times square root of 58 is 58 because what you're squaring this, so the square root part falls away. So that would be your answer in proper form. We don't want to leave that denominator with a radical. Alright, so let's continue on. Next, sine theta. Sine theta would be equal to Y over R. We defined that earlier in the previous video. So for us, that would be 7 over square root of 58. This time, because you've seen the pattern, we'll just jump right to it. It would be 7 square root of 58 all over 58. And make sure, just go back and apply this and you'll end here, but you want to get used to this pattern because you'll have to do it a lot. You don't want to have to sit there and have to do this every time. It takes too much time. So just get used to jumping from this directly to this. Get the pattern down and it'll be pretty easy. Alright, next, tan of theta. Tan of theta is equal to Y over X in our earlier definition. So for us, that's 7 over 3. That's easy, no more to do. 7/3 is fine. No denominator to rationalize there. Alright, now the reciprocals. The reciprocal of cosine theta is secant theta. So secant theta is R over X, and that would just be the reciprocal of this, so square root of 58 over 3. And no need to rationalize the denominator. We don't have a radical there. It's okay to have the radical up here, so that's done. Square root of 58 over 3. Next, the reciprocal of sine theta is cosecant theta, and that was R over Y. So just take this, the reciprocal of that, so square root of 58 over 7. Remember, our R value is square root of 58, our Y value is 7. We have that up here. So square root of 58 over 7. Coming over here, for the last one, cotangent theta. That's a reciprocal of tangent, so it would just be 3 over 7. And then, actually, it's X over Y, so in our case, 3 over 7. Once you have these three, then for these down here, you just take the reciprocal of whatever your answer was. That's a little faster than sitting there and having to plug that back in for X over Y, and R over X. Alright, so that's it for example 1. Let's go to example 2. Example 2, draw the angle theta in standard position where -2, -5 lies on the terminal side. Find the values of all 6 trig functions. All right, so here's our coordinate plane here. -2, -5 would be down here, so we'll label that -2, -5. And that puts our terminal side in quadrant 3. Remember, it's 1, 2, and 3. Well, do that again. 1, 2, 3. So we're in quadrant 3 there. And we have a triangle, a right triangle like this. So this is our x value, this is our y value. So for us, this would be a -2, and this would be a -5. So the r value is what we're missing. So for us, x is -2, y is -5, r is, we don't know yet. So we need the Pythagorean theorem. So r squared is equal to -2 squared plus -5 squared. So r squared is equal to 4 plus 25. So r squared equals 29. So r is equal to the square root of 29. Square root of 29 here, and I'm going to have to write really small, square root of 29. There we go. So picture is labeled. Now all of the trig functions. So I'll start going the same order I went in last time. Cosine theta is equal to x over r. You need to have this memorized because it'll go a lot faster if you do. So x over r for us is -2 over square root of 29. Apply our pattern from before, so -2 square root of 29 all over 29. That is proper. I don't want you to list it like this. I want you to rationalize that denominator. Okay, sine theta is equal to y over r. So for us, that is -5 over square root of 29. Rationalize it. -5 square root of 29 over 29. That's the pattern. Go back and look at that original on how I did it if you still need help with that. Tangent theta. Tangent is equal to y over x. So for us, that is -5 over -2, which simplifies to 5 over 2. The two negatives cancel. All right, and then the reciprocal of cosine theta is secant theta. So that would be square root of 29 over 2, and it has to be negative. So I just took the reciprocal of this right here. Cosecant theta is the reciprocal of sine theta. So take the reciprocal of that. So square root of 29 over -5, so it has to be negative. And then last one, cotangent theta is the reciprocal of this, so 2 over 5. And that's it for example 2. All right, example 3. So in this example, we have some more vocabulary. Coterminal angles. Well, we know what the terminal side is, so this will make sense to you, I think. The coterminal angles mean that they stop in the same place. So if we draw our coordinate plane here and do what it asks us to do here, draw a 120-degree angle in standard position. Okay, so let's do that first. So we have our angle here. So we start at 0. This would be 90, and this is 180. So 120 is somewhere in between 90 and 180, right? So we'll draw it here. It needs to be drawn, approximately to scale. So there is our angle theta, and well, it's not. Our angle theta is 120 degrees in this case. So there's our 120-degree angle, and it says identify the 4 quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It's appropriate to use Roman numerals there. So that is our standard position, positive 120-degree angle. So then draw a negative angle in standard position that is coterminal. So in other words, it stops in the same place. I'm going to use another coordinate plane so it doesn't get messy there. So it has to be, I'm going to use blue this time, it has to be ending in the same spot, but it needs to be negative. So I'm going to do it this way. So if I start here at 0 and I go negative, that's negative 90, negative 180, negative 270, right? So I'm somewhere between negative 80 and negative 270. So we're going to end right there. I'm going to do that so it's not in our way. Okay, so we have to think about this. Well, we need to do a little work here. So if this is 120 right here, the way we did the angle, this little bit right here has to be 60, right? That's 60 more. So this little piece right here is 60 as well. So we said that to here is negative 90, to here is negative 180. So negative 180 and another 60 would take us to negative 240 degrees. So all the way from here all the way around would be negative 240 degrees. Those are coterminal. 120 degrees is the same exact thing as negative 240 degrees. And you have to do a little work here to figure out that negative 240 and 120 are the same. Okay. Another way that you can look at it is you can tell in combination they equal 360 if you take absolute values there. That's another little trick that you can work through. So we'll label the quadrants here: 1, 2, 3, and 4. You just also need to realize that when you're talking coterminal angles, you can take as many revolutions around as you want, and as long as you end right here, those angles would be coterminal. So if you make a full revolution, so all the way around, plus another 120, you would just add 360 to that. So 480 degrees, for example, would also be coterminal with 120. Coterminal angles are important because the trig functions are the same. So cosine of 120, cosine of negative 240 are going to be the same because they end in the same place. So that's the advantage of knowing and studying the coterminal angles. All right, let's move on to example 4. All right, now for example 4, if sine of 30 degrees is equal to 0.5 or 1/2, what is cosecant of negative 330? So they're looking for us to apply our reciprocal trig functions and coterminal angles. So if 30 degrees is equal to 1/2, then we want to look at and see if negative 330 degrees and 30 degrees are coterminal. So if we start from the positive x-axis and we go negative, if we go all the way around, that's 180, 270, 360. So take 30 off of that. So to here was 360. Take 30 off of that, that would be 330, and it would be negative. So negative 330 degrees and 30 degrees are coterminal. Therefore, if sine of 30 degrees is equal to 1/2, then sine of, I need to put another 0 there, sine of negative 330 degrees also has to be 1/2. And if sine of negative 330 degrees is 1/2, then cosecant of negative 330 degrees has to be the reciprocal of this, because sine theta and cosecant theta are reciprocals of one another. So cosecant of negative 330 degrees has to be the reciprocal of 1/2, 2 over 1, which is just 2. So to answer the question, what is cosecant of negative 330 degrees? It is equal to positive 2. All right, example 5. If the sine of an angle is negative and the cosine is positive, in what quadrant is the angle? So let's label these quadrants again. 1, 2, 3, and 4. Okay, now I'm going to teach you a little acronym that will help with this. And it starts in quadrant 1, so you start in 1, that makes sense. And it's A, S, T, C. And what we use for this is go in order from 1, 2, 3, and 4. All students take calculus. All students take calculus. So what this stands for is this says that all of the trig functions are positive here. This S means that only sine and its reciprocal cosecant are positive here. This T is tangent. Only tangent and its reciprocal cotangent are positive here. And this C is for cosine, so only cosine and its reciprocal secant are positive down here in 4. So if we want the one where, let's see, sine is negative and cosine is positive, it has to be down here in quadrant 4. So quadrant 4 is the answer. It has to be in quadrant 4 because this is the only place where cosine is positive and sine is negative. Here, cosine is positive, but also sine is. So the only spot where this is true would be quadrant 4. So again, all students take calculus, and then it stands all the functions, trig functions, are positive in quadrant 1. Here, sine and cosecant. Here, tangent and cotangent. Here, cosine and its reciprocal secant are the only positive ones. All right, that's it for this video.